All right, so 4-3 homogeneous linear equations with constant coefficients. So we're going to start off with a first order differential equation in this form, right? So if you think about it, if I'm solving for y prime, right, I would get something like this, negative b over a times the function. And really, if you think of negative b over a, that's just a constant, so it's really like a constant times y, right? Actually, just to stay different, k times y, right? So y prime will be that. So if you think about it, right, what function will be very similar to its derivative? And if you take the derivative of e to the x, you'll get e to the x back out. If it's e to some constant, right, of x, if you did the derivative, right, we would get a constant, that constant times e to that mx, right? So what I'm going to show you is how this works, right? So I'm going to plug in these two for y, for y and y prime. Okay, so it's going to be a, let's just do it this way so you guys see it, equals a m e to the mx plus b e to the mx. And then that's going to equal 0. So think about this, right? If you factor out e to the mx, we get am plus b equals 0. And if you know exponentials, you know this can never be 0. So really we're just looking to see when is this am plus b going to be 0, and that will equal that negative b over a. So now I found a solution, right, to this problem, right? If I plug that back in for my m as my solution. So I'll wind up getting y to be e to the negative b over a times x. And then when you write your solution, you just want to make sure there's a c in front, right? C sub 1 e to the negative b over a. C just in case of you have some type of constant in front. So this would be the solution to that differential ay prime plus by equals 0. Okay, now with that, let me just show you a quick example on how do you have to do this process every time, and what if you see values for a and b. Okay, why isn't this? Oh, there we go. Come on now. There we go. Okay, so right here, if I give you this example, to solve 2y prime plus 5y equals 0, find the solution for this differential. You don't have to do all that work anymore. If you notice how it winds up looking, right, this is what we start with, this is what we're solving. So it's going to be 2m plus 5 equals 0. So m is going to be that negative 5 halves. And then I know that my solution is going to be y equals c1 e to the negative 5 halves x. And that's it. So that's how easy that first degree. Now, higher degree, homogeneous equations would look similar here, where all the a's, right, a sub n is a constant. Remember, this just means the nth derivative, right? So whatever your coefficient in front of that, it just goes with that nth derivative. And then plus, and then it just decreases a minus 1. The next derivative down, plus dot dot dot, plus, and then you could see how they all match up, right? and it equals 0. So you're going to get equations that look something like this. All right. So we're going to start with just the second order. Okay, second order. So you'll get in some form of a y double prime plus b y prime plus c equals 0. And very similarly, right, think about what I had going before, is that if it's e to the mx, our derivative would be m e to the mx. Second derivative, m squared e to the mx. So if I do the same thing as it did with the first and plug everything in, I'm going to wind up getting a m squared e to the mx plus bm e to the mx plus, I forgot my y, c e to the mx equals 0. And again, if we factored out, right, an e to the mx, you could see that here you just get a quadratic. A m squared plus bm plus c equals 0. Again, exponentials don't equal 0. I mean, this exponential will never hit 0. And then am squared plus bm plus c should look very familiar. Here we have a quadratic. And remember, you could factor, or you could use the formula, right? Formula is going to be, in this case, m equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, so that's really, if you notice the setup, you could kind of just skip all of what I did. You know, you don't have to do this every time. You just have to go from purple, right? So that's your equation, to purple and solve that quadratic. So let me show you. There's going to be 3 cases. So let me show you the first case. Okay. Not number 2, number 1. Okay, case number 1. All right. So case number 1 is going to be, let's do 2y double prime minus 5y prime minus 3y equals 0, right? So again, remember over here, you could skip all this orange highlighter part and just go from purple to purple, meaning really the only thing I need to solve for is 2 m squared plus minus 5m minus 3 equals 0. And here I'm going to just factor. I mean, you don't have to factor. You could use the quadratic formula. And I'll get 2m, let's see, plus 1m minus 3, right, equals 0. Okay, so here we get 2 values for m. m1 is going to be negative 1/2. m2 is going to, it doesn't matter the order. If you put m1 as 3, it's fine. Okay, now once you get this, okay, once you get this set up, you really get 2 values. You get y1 is going to equal e to the negative 1/2 x, and y2 is going to equal e to the 3. Where'd it go? E to the 3x, sorry about that. Okay, now when you write the solution though, when you're finding the solution to this, you write it as y equals c1 y1 plus c2 y2. And again, really, the order doesn't matter. Okay, and then that would be your general solution for this differential. So that's the case 1. If you noticed, right, this was factorable. I got if you did the quadratic formula, right, you could see that, let's say case 1, right, b squared minus 4ac is greater than 0, right? If you notice your a, b, and c up there, that would be greater than 0. So this is considered m1, and that's not how you spell and m2 are real and different. Okay, and that's when you have that first case, and your solution, right? Solution look like y equals c1 e to the m1x plus c2 e to the m sub 2x. Okay, so that's case 1. Case 1's probably the easiest case, okay, that we have. All right, let's look at case 2 example. Okay, let's do y double prime minus 10y prime plus 25y equals 0. So again, just go with, here you're going to have m squared minus 10m plus 25 equals 0. So just skip that whole part, and then you're solving this quadratic function, quadratic equation. And here you could see that my factors are going to be m minus 5, m minus 5. So really, you only get, because it repeats, right? This is considered repeating. Okay, m1 is 5. All right, so we know one of the solutions is going to be e to the 5x, right? So if we go back to 4.2 and let's use that, well, how would you find y2? If you remember that notation, it's going to be y1, the integral of e raised to the negative, right, p of x dx all over y1 squared dx. So here what I would get is y1 was e to the 5x. Okay, this winds up being e raised to the negative 10. I go back up here, right? P of x is up here. 10 dx over e to the 5x, the whole thing squared. So I wind up getting e to the 5x. This becomes a plus. So I get e to the 10x over, well, e to the 10x. That's very nice. And this is just going to be 1 dx, which you could see is going to give me e to the 5x times x, right? And just to clean it up, we get y2 to be x e to the 5x. Now, you don't have to do this every time, because I'll show you the setup after I write it out. So my solution is, like we found, y1 and y2. So again, you're doing the same thing. Y equals c1 e to the 5x plus c2 x e to the 5x. All right. So in case 2, case number 2, right? In case 2, okay, m1 and m2 are equal, right? Equal. And that, again, if you're using quadratic formula, b squared minus 4ac is going to be equal to 0. Okay, if that happens, right, your solution will look like y equals c1 e to that m1x plus c2x e to the m1x, right? So this is another pretty trivial, right? You could factor, or you could use the quadratic, and you could see in case 2, that's when you have repeating, if you want to think of them to be repeating solutions. You know, however you want to think about it. Okay, the weird one is I'm not going to prove the whole thing like I did the last one. It's just tedious to do, but I'll just show you how it works here, right? So the third case. Okay, the third case is going to be where we can't factor. I mean, you could use quadratic for all these. Okay, so again, I'm just going to start with m squared plus 4m plus 7 equals 0. And now this is not factorable. Okay, so what I want to do is just solve, right? So I'm going to do m equals negative b, so negative 4 plus or minus square root b squared, so 4 squared minus 4 times 1 times 7 over 2 times 1, right? 2a, so I get negative 4 plus or minus square root of 16 minus, what do we got there, 28 over 2, right? So you have negative 4 plus or minus square root of negative 12 over 2. So just a little review, right? Break this down. Okay, break that down from algebra, right? So you're going to get negative 4 plus or minus. It's going to be the I, right? When you see a negative in there, so you get 2I root 3 over 2, which simplifies down to negative 2 plus or minus root 3, I root 3. Okay, so a couple things. When you write this first number is considered alpha. The second number is considered beta, right? They have like a beta like that. And then it's multiplied by I. So here alpha would be negative 2, beta would be root 3. So when you write your solution, okay, your solution is going to look like this. Y equals e raised to the alpha x parentheses c1 cosine beta x plus c2 sine beta x. Okay, so what we get for us is e to the negative 2x parentheses c1 cosine beta was root 3 times x plus c2 sine root 3 times x. So it's a little bit different in the sense, but really if you know that setup, you will get that solution for your differential. All right, so for case 3, okay, for case 3, what winds up happening, okay, is really you wind up getting 2 m1 and m2 are conjugate complex numbers. Okay, so really if you did it how we did that first case, you would get c1 e to the conjugate, right? So you would have that like alpha plus beta I and then times x plus c2 e to the same thing, alpha minus though beta I times x, right? You would have something like that. But Euler, okay, right? This is Euler, that's a little angle theta. So e to the I theta is cosine theta. If you go back to pre-calc, I sine theta, maybe if you go back to pre-calc, I don't even know if they teach that anymore, which would give us, after you simplify and do all this substitution and plugging in, I'm not going to waste time with that, you get this e to the alpha x cosine beta x plus c2, sorry, e to the alpha of x sine beta x, and then that's where I just get that e, if you factor out e to the alpha of x, c1 cosine beta x plus c2 sine beta x. Okay, so that would be, now don't do all this work every time, just know if you get complex conjugates, right, you're just using that notation there. Okay, so this is Well, let's do one more example. I'm going to do initial value, okay, just to end it on an initial value. Okay, so here, let's do a IVP problem, right? And here if we have 4y double prime plus 4y prime plus 17y equal to 0. I get y of 0 is -1. Y prime of 0 is going to be 2. All right. So, again, 4m squared plus 4m. So I just skip all that, plugging in the e to the mx, right? I don't want to do that. And then here you can see this is not going to be factorable. So what we wind up getting here is m equals -4 plus or minus square root of 16, well, 4 squared minus 4 times 1 times 17 over 2 times 4, right? So we wind up getting -4 plus or minus 16 minus 68 over 8. And here I wind up getting -4 plus or minus square root of -52 over 8. And what I wind up with so I get -4 plus or minus must have did something wrong. Oh, you see what I missed? There's a 4 in there. My bad. Okay, so this is going to be 272. And we get -256. And that gives us 16 I over 8. So I get -1/2 plus or minus 2i. Okay, so here you could see your alpha, -1/2, beta is going to be 2. So I'm going to write it as y equals e to the -1/2 x, parentheses c1 cosine beta, so 2x plus c2 sine 2x. Okay, now we need to find our solution to this initial value problem. So I do need the derivative, right? Because I'm going to plug in, but let's plug in the initial value y of 0 equals -1. So I'm going to have -1 equals e to the -1/2 times 0, c1 cosine 2 times 0 plus c2 sine 2 times 0, right? And it looks like that. So sine 0 is 0, that's out. And then this is just going to give us -1 equals 1, right? Cosine 0 is 1, so we know c1 is 1. Okay, so we get that. Now we do need to take the derivative. So the derivative here is product rule, so I'll have -1/2 e to the -1/2 x times this whole thing. Okay, plus e to the -1/2. You'll have a -2 c1 sine 2x plus a 2c2 cosine 2x. So now if we plug in 0 giving us 2, we're going to have 2 equals negative 1/2 e to the 0, c1 cosine 0 plus c2 sine 0, plus, I forgot my x, e to the 0, negative 2 c1 sine 0 plus 2c2 cosine 0. So just be careful here on what everything is, right? So here you get negative 1/2, right? Because e to the 0 is 1, cosine 0, so that's c1, plus sine 0, that's just 0, plus e to the 1 is 0, sine is 0. I mean, e to the 0 is 1, sine is 0, so that goes out. And then you have plus 2c2. Now, we already knew c1 was negative 1, so that's going to give me 2 equals 1/2 plus 2c2, so I get 3/2 equals 2c2, so I will get 3/4 to be c2. All right, now that you have c1 and c2, right, we are just going to go and plug them back into that general equation. So I get e to the negative 1/2 x. I have negative cosine 2x plus 3/4 sine 2x. And then there is our initial value solution.